In a previous video, we saw that dorsal root ganglion cells, somatosensory receptor axons, mechanoreceptors that ended on Merkel cells allowed us to detect things like Braille dots, fine tactile discrimination. Okay, fine meaning really small, tactile, touch discrimination. You can tell the difference between 2 dots and 3. It also plays a fundamental role in your ability to tell if something you're holding in your hand or that you're touching is made up of straight lines or squiggly lines, the sort of 2D shape that we call form, and it plays some role in your ability to detect texture. That is something rough or is it smooth? Okay, great. So that's what those guys do. You'll notice here's a guy that deals, it ends in a Meissner's corpuscle, and it says dynamic deformation. What does it mean by that? Well, down here it probably does a better job of telling you in words that would be understandable to a bright young person. And that is, these guys are capable of detecting movement parallel to the skin surface. If you pick something up and it starts to slip through your hand, these mechanoreceptors that end in Meissner's corpuscles, they generate a lot of action potentials. And the result is you're able to adjust your grip until the thing stops moving. Okay, that's great. Then you've got the Pacinians. And it says here the Pacinians respond to vibration. They have a bell. I'm not going to say bell. I'm going to accent this, but I'm going to translate it. The Pacinians allow you to use tools. So think of a tool like a screwdriver. When you try to assemble an IKEA desk or an IKEA bookcase, how it feels as you take a tool and insert it like a hex wrench, and you insert it so that it matches the hexagonal pattern of the bolt. You can feel it in the pattern of vibrations really well, as opposed to when you miss, the pattern's very different. Or let me use a prosaic example, and that's keys. Let's say it's dark, you get to your home, where you guys are now, and you try to insert a key into a lock, but it bangs up against the side of the lock. Well, that's a pattern of vibration. It's very different than when the key slips right into the lock. So you're going to move until the key slips into the lock, and the pattern of vibrations that's produced by that is so distinct that you'll know that you've achieved what you set out to do, which is insert the key in the lock. So every tool that you use, writing utensil, even a steering wheel, the pattern of vibration of the steering wheel tells you about the roughness of the road. All of those rely upon Pacinians. Okay, great. Here's Raffini's again. I'm going to tell you the jury's out as to what they do. It says stretch here if you say so. You do have hairy skin, a lot of it, and a lot of that is responsible for detecting things that are present and moving along the skin surface. I think of hairy skin as mosquito detectors. Mosquito doesn't have a lot of weight, but it lands on your hairy skin. The deformation of the hairs allows you to pick that up immediately. All right, great. Last thing out here. And here we have free nerve endings. They don't have any kind of capsule at all. What do they detect? You are going to see that the inclusion of the word pain here riles me to no end, because there's nothing about a stimulus that's intrinsically painful. What these guys pick up, however, are noxious stimuli, those things that have or could cause tissue damage. Right? So, fundamental division of labor. Lots of different receptor types in your skin. Every square millimeter has these types. Okay, great. What are they doing? Each of them performs a particular transduction event. It handles a particular kind of energy. And as a result of each of them handling a different kind of energy, your perception of what goes on in your skin surface or your muscles or your tendons is really quite exquisite. You're able to discriminate various types of stimuli.